Now let me start from here. Closed path integral of v bar dot dl bar, okay, that's equal to surface integral of del cross v dot d. Am I right? So let me see the same theorem in a ulta way. Now for a given closed path, there are infinitely many surfaces, isn't it? You can have infinitely many surfaces for a given closed path, am I right? So your hemispherical bowl or pot shaped or balloon shaped, whatever, am I right? You can have infinitely, or plane itself. Suppose if it is circular loop, okay, plane itself, that's also surface, am I right? So for a given closed path in a space, you can have infinitely many surfaces. Okay, if I write like this, what is this surface? Are you getting my point? If I go from here to here, it's very clear. For a given surface, there will be only one closed path. We have taken all conventions, how to take those things, isn't it? Now let me start in this way. For a given closed path, any shape, okay, any shape, you have infinitely many surfaces whose boundary, all of those surfaces will have the same boundary line, isn't it? Now, which one you choose? Is that okay? Earlier we had not this kind of question, right? One volume, one surface, in case of Gauss theorem, isn't it? Now, for a given closed path, so you can take any surface, this is true. But you have to follow that convention, right hand thumb rule. Is that okay? So now, what do you mean by that one? I mean, this theorem is true for any surface for a given boundary line. What do you mean by that one? The surface integral is independent of the surface chosen. I told there will be one special class of vector field whose surface integral will be independent of the surface chosen, and curl of any vector field is that special class of vector field. Wait a second. So again, if I see the theorem in a reverse way, so for a given path, you can generate infinitely many surfaces. Is that okay? So, and this can be any one of those surfaces. So, what do you mean by that one? For all of such surfaces whose boundary line is same. Is that okay? So, this surface integral is same. That means surface integral is independent of surface chosen. It depends on the boundary. Is that okay? So, can you write a couple of sentences? Integral of del dot del cross v dot d. Write yes here. Or don't write yes. Just open surface integral. Okay. Depends only on the boundary line. Depends only on the boundary line. And not on particular surface chosen. I mean, the question comes, I mean, we can take any surface means, am I right? The question comes on which it depends on, isn't it? You can take any arbitrary surface means, the question comes, which I mean, so how, so on which factor it depends on? It depends on this path. For a given path, take any surface whose boundary is this path. So this theorem is true. Are you getting my point? Suppose if you take a So circular one. So take a plane of the circle itself. That's also okay. So take a hemispherical bowl whose what you call boundary is this one. That's also okay. Take any shaped surface whose boundary is that one. So then this surface integral is same for this surface, and that planar surface. Is that okay? So it is independent of the surface chosen. It depends only on the boundary line of the surface. So that is the first statement, first observation. So next one, once look at here, you can just see this one. If I make this one as closed surface integral, what would happen? This is an open surface integral. You can define the path. Am I right? If you make it as a closed surface integral, what would happen? There will be no closed path. Am I right? There will be no boundary. That's why this part will be 0. Is that okay? Second part of the statement is closed surface integral of any surface again. Any surface should be equal to 0. For any closed surface, write like that. For any closed surface. So write down in your way, closed surface will not have any boundary. It was a relation to surface integral to the some path integral, where that path was boundary line of the surface. Now you have closed surface which doesn't have any boundary. That's why that path integral would be 0. Or if you just say, if you want, suppose I have a balloon here. Is that okay? I have a balloon here. I'm going to shrink that mouth of the balloon to 0. Then that becomes closed surface. Now it is open surface. It is open here. Now I'm going to shrink that mouth to 0. Then what would happen? That becomes closed surface. Then what is that path? That path also shrinks to 0. Am I right? You can take that angle. When this path shrinks to 0, when this boundary line shrinks to 0, this becomes closed surface, isn't it? You can take balloon idea. So just tie this one. Then this mouth will shrink to 0. Then that becomes closed surface. Now it is not closed surface. You have a boundary line of the surface. Total surface, you have the boundary line. Is that okay? Once you make that one shrinks to 0, this path integral shrinks to 0. Path itself shrinks to 0. Is that okay? So that this part will be 0 for a closed surface. You can argue like that. Okay? Write down, closed surface will not have any boundary. Isn't it? Again, we are going to use this one in electrodynamics chapter, okay? The whole story. That's why you better to keep on, seeing these theorems again and again. So what we do in case of Maxwell correction or something, we are going to take one path integral. So path integral will be one side. So in other side, what would happen is you may take one is planar, isn't it? You are going to take path integral. In other side, you can take planar surface, but it will be independent of the surface chosen, isn't it? Usually it will be, so if I take the particular one, what is that? Faraday law. What is Faraday law? Del cross E is equal to minus dou B by dou T. Am I right? We are going to take surface integral of this one. Okay? Dou B by dou T dot dA, like that. Okay? Remember, the whole story is this one, this vector calculus. Okay? That's why 100% understanding is needed here. So this one we are going to convert that one into line integral. This is nothing but our EMF. Okay, line integral of the electric field. This again by Stokes theorem. Now this surface should be same because we are doing the surface integral. You have one vector field, other vector field. You are doing the surface integral. This surface should be same. Now this surface integral, I am going to convert that one into path integral. Am I right? So now once you convert this one into path integral, now path integral and surface integral are connected by your Stokes theorem. Am I right? Now what is this surface? This is any surface whose boundary is this path. And in Maxwell correction, we are going to take two different surfaces and we are going to do something with that. Is that okay? And this should be true for any surface, remember. Again, so what is that one? What is that property? That is a property of magnetic field actually. Magnetic field is a special class of vector field whose surface integral is independent of the surface field. So you can take dou by dou t outside, or you can take it as d by dt, isn't it? Minus d by dt of surface integral of b bar dot da bar. Okay, we shall study this one. Now look at here, it is independent of the surface means, I mean depends only on the boundary line of the surface. Independent of the surface chosen means magnetic surface integral of the magnetic field is independent of the surface actually. Again, that's special class of vector field. Okay, those again we have to apply this one, this whole story. Okay, once you define a path, you can have infinitely many surfaces. All of those surfaces will have the same boundary, which is that path, and along all of those surfaces, surface integral of curl of any vector field is same. Okay, so that's why surface integral of curl of a vector field depends only on the boundary line, not on the particular surface field. Okay, just have a hold on this one. Now quickly we shall solve this one. Now what they can design question, any idea? So they will design this one. Okay, they'll give one lengthy closed line integral. That will take time because we need to divide those line integral into different parts. Am I right? Now if you take curl and if you do surface integral, that would be one step answer. So shall we do one example quickly? V is equal to 2xz plus 3y square y cap plus 4yz square z cap. You have to do this one. Once you do this one, all of those notations will be there in your mind. And I mean, because here it is you should follow some sign convention. Am I right? X cap, y cap, z cap. Look at here how it works. So take a square shaped surface, okay, which is on zy plane. Length and breadth are 1 and 1. Okay. Now he said verify Stokes theorem of this vector field. Okay, for this surface. Now what should we better to do first? Line integral. Okay, but we have to feel that one, how it is, how difficult it is. Then we have to go for surface integral. That will be very easy. First we shall choose line integral. I better choose like this so that my dA vector will be along x cap. Okay, that's again our choice. You can choose ulta also. So now let me choose my line integral like this. Okay, closed line integral, boundary line of this surface. You can take any surface. Okay, but to what you call prove that one, we should not take any lengthy surface whose boundary is this path. Am I right? What is the easiest surface whose boundary is this path? That is the plane itself, isn't it? That's how we take usually. While finding, we should not end up with any trouble. Is that okay? Surface integral should be easy. So that's why easiest surface for any closed path in a plane is plane itself, isn't it? Again, that closed path need not be in a plane. Okay, closed path may deviate from the plane, but most of the case it will be on the plane. Our closed path will be on the plane. Okay, that's why we will show that Stokes theorem for a planar surface whose closed path is also in the same plane. Okay, now look at here. So just let me divide first one, second one, third one, fourth one. Okay, first one. Again, anyway, I have to write v dot dl. You better write down that one because that is needed throughout that one, isn't it? V dot dl, that is needed. What is this one? I think dl vector. How do you write dl vector? Dx x cap plus dy y cap plus dz z cap. I hope you remember only two dimension. That becomes 2xz plus 3y square into y cap dot y cap dy plus 4y z square multiplied with z cap dot z cap dz. That is your v bar dot dl bar. Okay, this is your v bar dot dl bar. Now wait a second, throughout your line integral, x is 0, am I right? You can put x equal to 0. Look at here, you are moving in a yz plane, isn't it? X equal to 0. That's why throughout your line integral, you can put x equal to 0. So that's why I can just do it like this, am I right? So 3y square dy plus 4yz square dz, am I right? So along first path, z equal to 0, dz equal to 0, am I right? Along first path, z equal to 0, dz equal to 0, y will run from 0 to 1, y will run from 0 to 1, 3y square dy plus z is equal to 0, y cube by 3, that's 1, check it out. You better write in the diagram itself, isn't it? What would happen in that path? What is the second path? In the second path, y equal to 1, dy equal to 0. Y is not changing, but x is changing from 0 to 1. Sorry. Z is changing from 0 to 1. That's why second path, y equal to 1, 3 into 1, dy equal to 0, plus 4y equal to 1, z square dz. Z is running from 0 to 1. What is this one? Z cube by 3, that's equal to 4 by 3. Check it out. 4 by 3. Do it yourself. You have to define variables on each path. That's it. Carefully. It's done. Third one. Integral from, remember, z equal to 1, dz equal to 0. Z equal to 1, dz equal to 0. Y is running from 1 to 0. Don't forget, okay? Don't write 0 to 1, 1 to 0, because your path is from here to here, not here to here, okay? Be careful. That does matter, am I right? This path integral will be different from this path integral, isn't it? So that's why 1 to 0, z equal to 1, anyway, dz equal to 0, this part equal to 0, 3y square dy. Minus 1, check it up, y cube by 3, 0 to 1, upper limit, minus lower limit, minus 1, check it out. Fourth path, y equal to 0, dy equal to 0. If y equal to 0, this whole part is 0, am I right? Line integral is 0. In the fourth path, that's equal to 0. What's the combination? What's the answer? Total closed line integral of v bar dot dl bar, adding all of these, 4 by 3. This is the path. This is the closed path. Okay. Now look at here. It took some time. Am I right? 1, 2, 3, 4. 4 different steps. Then adding that one. Now what is the next one? Take a curl of the vector field. Again, curl of the vector field may take some time, but not much. Okay. Finding curl. X cap, y cap, z cap. Dou by dou x. Dou by dou y. Dou by dou z. What is x cap? 2xz plus 3y square. Sorry. X cap coordinate is, x cap component is 0. Only y cap and z cap. What is this one? 2xz plus 3y square. 4yz square. Am I right? Just do that one. X cap into dou by dou y. Dou by dou y, that means 4yz square minus 2x dou by dou z minus y cap into dou by dou x 0 plus z cap into, do it yourself, 2z. 4yz square minus 2x x cap plus 2z z cap, that is curl. Check it out. whether I'm right or wrong. Okay, y derivative with respect to y, am I right? Yeah, 4z square. Again, here he defined very random question, okay, to show that one. But in exam, sometimes they will define in such a way that curl will be very simple vector field, okay, or surface integral will be very simple. So that you have to use Stokes theorem. You have to explore the Stokes theorem to make the problem easy. But be careful about dA vector. Now, what is dA vector? If you have taken your again, you can take any surface, okay? It is independent of the surface, remember. But planar surface is the easiest one. We are going to show the Stokes theorem for plane itself. So, again, in that plane, what is dA vector? Why it is along x cap? Why not minus x cap? Because that plane have got two perpendicular, isn't it? Why only x cap? Because so of our right hand thumb rule, okay? If our line integral runs like this, then our thumb should fix the direction of dA vector. Now let me do that one. X cap dot product with x cap, am I right? So surface integral of, this is the surface, okay? This is my surface. Del cross V dot dA, that's equal to, what is this one? X cap dot x cap, z cap dot x cap equal to 0, 4z square minus 2x into dy dz. Y will run from 0 to 1, x will run from, z will run from 0 to 1. Am I right? Square and cube is very easy to take the limit, remember, okay? So 0 to 1, can I take it like this? But what is x over there in that plane? 0, x equal to 0. That's why 0 to 1, x equal to 0, 0 to 1, 4z square dy. Obviously, that is 4z square will come out and integral 0 to 1 dy equal to 1, isn't it? So dz. So 4 will be outside. Integral 0 to 1 z square dz. What is this one? Check it out. Now, there is one very good question here. Okay. What if surface have got two different boundary lines, just like a cylindrical surface which is open in the both sides. Suppose a PVC pipe cut down in the both ends. Then how to apply this theorem? I think you better to see Sham series book, okay? Because we will never have that kind of application here. Yeah, I think somewhere he has given Sham's outline. I think the author name is Spiegel. Let me share that one. Vector analysis like this. Yeah, so very good question. I don't know how to apply this one to that kind of surface. Okay, are you getting my point? Suppose I have a cylinder like this. Now what will you do? I think somewhere we had less physical interpretation. That is the problem, isn't it? I have just taken a mathematical part here. Just read out his interpretation. Okay, you may get some idea how to choose the surface. What would you feel? You have to take both the path integral. Both in the same direction. Yeah, we have to be careful. Yeah, let me think of it. Yeah, speak out. Isn't it? So now they will design question like this. They will give lengthy path integral, so that you have to avoid that path integral. You have to find surface integral. Okay. Sometimes they may ask closed. Yeah. Now look at here. Let me just extend this one. Remember, just list out all of these again. Read again and again and again. Okay. Stokes theorem, Gauss theorem, and properties. Now, what is the property? So this vector field is independent of the surface chosen for a given boundary line. That is the property. Those things should be there in your mind. You have to apply, you have to use this whole vector calculus just like how you do subtraction and addition. Is that okay? You have to use whole vector calculus like this, then it will be very easy. Okay. Now do problem number 1.34. Triangular region. Okay, let me do it in the evening. Okay. So surface integral should be done very carefully. Look at here. Here, what is your surface integral 0 to 1, 0 to 1. Am I right? Now he has given surface like this. If you run y from 0 to 1, z from 0 to 1, it will cover a square region, remember, not triangular region. For triangular region, what will you do? No, I mean, you will have a functionality. It's not just finding the area, remember, isn't it? So your that scalar, that will take different value in different regions, remember. It's not half of the square. Are you getting my idea? Whatever the scalar you have, that is depending on z. Look at here. In different region of this space, you will have different values. So you have to take the limit properly. Is that okay? So now you should think how it runs actually. So if you take one line here, that line will shrink and it will add up triangle. Isn't it? Like that you have to think. Just try that one, okay? Just try that one. This is similar to that, what you call, prism shaped volume integral. Just try to do that one. Let me explain in the evening. 1.34 and you can do 1.35 also. 34 and 35th problem in the first chapter, okay? And he has given one more integral. I hope we have already done that one. That's okay. And then he will go for different coordinate system. Now look at here. Yeah, we better to close it here, okay? Wait a second. Again, let me write that Stokes theorem. Del cross V dot dA, that's equal to closed path integral of, am I right? So now I have a special class of vector field whose curl vanishes always. What is the best example? Electrostatic field. Null vector. I have a special class of vector field whose curl vanishes. Then look at here, its closed path integral will be 0 always. Any closed path you take, you can generate a surface whose boundary is that closed path. Am I right? When you take this part of the theorem, since curl is 0, that will be 0. Is that okay? Whenever we have this situation, whenever curl of a vector field is 0, the very next thing is closed path integral of that vector field equal to 0. Scalar equal to 0. The very next thing is, we have to show this one, we have to argue this one. If closed path integral equal to 0, then path integral is independent of the path chosen. It depends only on, we had a reverse of that one, do you remember? When path integral was independent of the path, depends only on the boundary line, closed path integral was 0. Am I right? But the next one, A to B, V bar dot dl bar is independent of path from A to B and depends only on the endpoints. Are you getting my point? These are one-to-one consequences. Now here to here, you need some argument, okay? Here to here, it's very easy, am I right? If it is independent of the path from A to B, it depends only on the endpoint. Make those endpoints same. And we have seen that was first theorem, am I right? So from here to here, it is very easy. But here to here, it takes some effort. Just try to explain how that can happen. When closed path integral equal to 0, how open path integral is independent of the path. Little difficult to argue. And there are theorems like that. Okay? In vector calculus, if you see again any mathematics book, they will define a theorem. Okay? These two are one-to-one consequences. Over. Now, when that would happen, when this will be independent of the path, look at here, when that vector field can be written as some gradient of scalar field, isn't it? So so our first theorem was we had a gradient of a scalar here, do you remember? So when that vector field is equal to gradient of some scalar, this will be always true. That's why we think in a reverse way. Whenever this happens, we can write that vector field as a gradient of scalar. That is our potential formalism. In our electrostatic, that is our potential formalism. Okay, it all from this one. It all from this one. Now look at here. By seeing this one, can I write V is equal to some del of T? Isn't it? Because so only then this would be independent of the path chosen, isn't it? That was our first theorem. Now I'll go back and I'm going to connect these two. Whenever curl is 0, I'm going to say vector field can be written as gradient of scalar. Is that okay? That is our potential formalism, but we place one more negative sign, E equal to minus del V. Those are other consequences, okay? We shall study that one. So now, we were trying that volume integral, am I right? So volume integral of a prism shaped thing. Now let me start with very simplest case, okay? Let us learn that one. Even I too forgot that one. So that multivariable calculus was there in BSc, isn't it? So I hardly attended classes in BSc. I mean, very less classes that I have attended. So there was senior notes. I just read that notes, not even saw it. BSc mathematics. So they used to ask only theorem and very less tricky question. So just reading senior notes was sufficient to qualify BSc exam, BSc mathematics exam. Isn't it? Whatever the mathematics we are discussing, that is BSc level. Okay, not advanced, still advanced mathematics. Again. Yeah, so multivariable calculus, am I right? So now look at here, let me start with this one, x, y, x here, y here. Now let me take one, so triangle, so with 2 here, 2 here. You know how to find area of the triangle, okay? How to find area of the triangle. So first let me find area, okay? So now look at here. So if you have a square, then what will you do? Suppose, let me start with a square. X here, y here. Let me start with a square. 2 here, 2 here. I mean, not ordinary method. Now we have to go through calculus method to find the area. Okay. Don't ask why. Because, so again, now we have to first define the integral. Now functionality will come inside the integral. Now we don't have to take functionality. We can take dx, dy. You have to integrate. Am I right? Elementary area. So there is dx into dy. You have to integrate. Am I right? Then you will get total area. That's what. I mean, I'm just doing this one, integral of dx dy to find the area. But in our application, we will get some more scalar here along with this dx dy. Am I right? We need to integrate that one along with that one. So that's why first we shall see how to run the limits for just finding the area. Okay, because we know what is the answer of the area. Am I right? What is the area? Okay. Now look at here. So how do you find the area here? Actually, how does that double integral works? Am I right? So double integral of dx dy. Am I right? Now you can write x running from 0 to 2, y running from 0 to 2. Am I right? That's done. Isn't it? So now what you are doing here? So 0 to 2, look at here, let me write in bracket 0 to 2 dx. When I have this integral 0 to 2 dx, what you get actually? Any idea? You will get a length along x-axis from 0 to 2. Can I say like that? dx, dx, dx. I mean, so integration is a generalization of summation. Am I right? So that's why. So if you are integrating dx from 0 to 2, what you are doing? You are just finding the length along that one. Am I right? So when I integrate this one, that means I am just finding this length. Remember, I am just finding this length. This part in this part, I am just finding this length. So 0 to 2, obviously that is 2. Am I right? So after this one, look at here. So this one multiplied with dy, isn't it? This length multiplied with dy, and you are integrating that one from 0 to 2. That means you are adding this one like this. Are you getting my point? You are adding these lengths like this. In the second part of the integral, you are adding these lengths like this along y-axis, so that you will get total area. So that's how it works actually. Is that okay? So now, when you do first integral, you are just finding one line. Okay, that integral becomes one line. Line means length actually. Okay, exactly. Now in the second part of the integral, that will be swept in the other axis, in the direction of other axis. So that entire thing becomes your or you can, I mean, if suppose this is constant, you can take it outside. Am I right? And then you can do other part. That's also okay. That's again length into breadth. That would be length into breadth, isn't it? So now look at here. We shall try to apply the same thing here. Same logic. How? First we have to find one length, then we have to run that length so throughout the area. So for that, look at here. We need equation of this line. What is the equation of that line? Y-intercept is 2. Slope equal to minus 1. So that's why y is equal to m into x plus c. Y equal to slope equal to minus 1. Minus x, what is the y-intercept? 2. Y is equal to 2 minus x. Or take this coordinate 2, 0, 0, 2. You know how to find the equation of the straight line when you have two endpoints, isn't it? How? x2 minus x1 is equal to something like that, isn't it? X minus x1 is equal to y2 minus y1 divided by x2 minus x1, like that. Okay, just to follow those kind of formula, whatever I feel comfortable with, y equal to mx plus c. C is y-intercept. Is that okay? So now this equation of this line is equal to y is equal to 2 minus x, isn't it? Y equal to 2 minus x. So now look at here. I have to find this kind of line here. Okay, I have to find this kind of line here. But what I do here is, if I find here, you will get 2. Am I right? But again, that is variable here, isn't it? Now it's not just like that line is added to get the area here. Now here again, lines are added to get area, but that line is shrinking. Am I right? You have to shrink that one. So look at here, one line, other line. So you have to shrink the length of that one. So that's why what we do here is, we are going to take length of one arbitrary line. Then we will run that line from this point to this point along y-axis with a variable length, so that we can sweep the area. So I'm just giving the geometrical interpretation. Okay, look at here. So I'm just taking, wait a second, what did I said? I'm just taking arbitrary, why I'm taking, so here you can take it anywhere. Look at here. Actually, 0 to 2 dx, that can be anywhere. Not only on x-axis, remember, that can be anywhere. When you sweep that one, so I mean along y-axis, that you will get total area. Is that okay? So now, so here also I'm going to take this line, okay, this line, integral over this line. That means x is running from, what is x value? 0. What is x value here? Let me take, this is y, arbitrary y, and y will run from 0 to 2. Okay, let me take that arbitrary y. So now, if this is y, what is this one? So 2 minus y, x equal to 2 minus y, according to this equation. Am I right? X equal to 2 minus y. If this is y, x equal to 2 minus y. I am going to find this length of the straight line at y, and then I am going to sweep along y-axis. Is that okay? Now what is that length? You can say that's 2 minus y. Am I right? So 2 minus y, look at here, 2 minus y. So now when you just integrate this one with respect to dy from 0 to 2, you will get the answer. You will get the area. Are you getting my point? 2 minus y is the length of this one. Now look at here. When y equal to 0, this quantity is 2 here. Am I right? When you put y equal to 0, this line becomes this line. When you put y equal to 2, this line becomes 0. I mean, length of that line becomes 0. You got the area here, remember. But how we do this one is, again, we have a double integral, am I right? Double integral of dx dy. Dx dy is our elementary area, am I right? So now while doing that dx, what we do here is, again, we are just finding the length of this one. That's why we are running x integral from 0 to 2 minus y. So that I am finding this length arbitrarily. Is that okay? 0 to 2 minus y. You can do ulta also, vertically. Okay, by taking one vertical line. You can do like that also. Once you integrate this one, 0 to 2 minus y, what would you get? Any idea? Again, then you can integrate. Again, this line will be integrated, y running from 0 to 2. Okay, but this line, x running from 0 to 2 minus y, that is an arbitrary line segment here. And so next case, you have to sweep that one, so that 0 to 2, y runs from 0 to 2, so that you will get entire area. Is that okay? So now look at here, 0 to 2 minus y dx. What is this one? 2 minus y, am I right? So dx integral answer is x running from 0 to 2 minus y. Am I right? 0 to 2 dy. What is this one? So 2 minus y, 0 to 2, 2 minus y dy. Am I right? So find this one answer. So 2 into, I think, dy 2 minus y square by 2, y square 4. 0? No. Yeah. 2 into y running from 0 to 2 minus y square by 2. Y square by 2 running from 0 to 2. What is the answer? 2. That's correct. Half length into height. Am I right? That's the area of that one. Isn't it? So again, you know how to find area of this one. That was not our target. Am I right? We will get a functionality here. We will get some function of x here. Isn't it? So when we integrate some scalar function, we will get some function x. Then we have to follow the same method. Is that okay? Now if it is a, what you call, prism, then can I extend this one along z axis? That will become prism. Am I right? I have a triangle here. So just extend this one along z axis, you will get a prism. So that was our problem. So let me solve it again. Wait a second. One volume integral problem. So any question here? If you need a volume of a cube, then what will you do? First you will do dx dy, then you are going to sweep that one along z axis. Isn't it? Adding those areas, that becomes volume. So adding these lines, so lengths of those lines, that becomes, so your area, sweeping those lines, you got to say like that, isn't it? Now here also you have to sweep line, but that line segment have got variable length. So that's how you can do here, isn't it? Now look at here, here itself you can see, this is the main part actually, 2 minus y dy, am I right? 2 minus y is the length of this line. When you run y from 0 to 2, when y equal to 0, that length equal to 2, am I right? So when y equal to 0, length equal to 2, again you are adding all of these. When y equal to 2, length equal to 0. You are adding all of those lengths, that becomes area. Is that okay? So now again, so let me try to share some animations on this one. Yeah. So now let me take that problem. This is example number 1.8. Have you tried? Example number 1.8. Example number 1.8. We have some scalar t is equal to x, y, z square. T equal to x, y, z square over the prism in the figure shown. He has drawn one prism here, x cap, y cap, z cap. Is that okay? Over So here he has written 1, 1 and 3, okay? 1 here, 3 here. Now you have to integrate this scalar function. Look at here. If you integrate x from 0 to 1, y from 0 to 1, z from 0 to 3, that becomes not prism. That will become what we call. So cubic. So that will become like this actually. So what we call structure? Cuboid. That will become cuboid, remember. Is that okay? If you run x from 0 to 1, y from 0 to 1, z from 0 to 3, that will become cuboid. I mean, you are sweeping throughout cuboid. Now look at it, you can ask one question. Why can't I find the total integral for cuboid and then I divide by 2? That will not work. Why? Because this function will take different values in different regions, remember, and you are adding that one. Is that okay? Integral of, so t into dx, dy, dz. This t will take different value in different regions, remember. In case of volume, you can do like that, just finding the volume, integral of dx, dy, dz. You can do that one. You can find total volume and you can divide by 2. Isn't it? But here you can't do because this will make a difference. Is that okay? That will take different value. So that's why, but again we can follow the method of finding the volume. How we can find the volume? First we have to find the area of the base, am I right? Then you can sweep that triangle along z axis, you will get the total volume. Isn't it? Now how do you find area of this one? Again our earlier trick. Is that okay? How do you find area of this one? So can I take x here, y here? Yeah, or let me just do it here. Is that okay? So now let me take one line, so perpendicular to y axis. Is that okay? So what is this line equation? Any idea? Y equal to 1 minus x. Y-intercept y is equal to mx plus c. C equal to 1. Slope equal to minus 1. Can you just imagine? This is a plane, xy plane, isn't it? If you draw it like this, that will become like this. Y here, x here, 1 here, 1 here, isn't it? Slope equal to minus 1. That's why this is y is equal to 1 minus x. Now let me find the length of this one. Okay, while finding that length, how should I integrate? I should integrate dx, isn't it? I have to integrate x is running from 0 to, if this is y, what is this one? What is this one? 1 minus y. If this is y, corresponding, so if this coordinate, I mean, you can write this coordinate as 1 minus y comma y, am I right? X comma y, x equal to 1 minus y. You can write like that, isn't it? So that's why I'm finding this length. That's why I have to integrate x from 0 to 1 minus y, isn't it? Then you will get this length. Then you have to integrate that one with respect to y from 0 to 1, so that you can sweep that through the triangle, isn't it? 0 to 1. Then you can integrate that one from 0 to 3 with respect to dz, so that you can add those triangles one after other, so that you will get the volume, total volume. So this is how we can find the volume, am I right? Now this scalar is going to play the role here, that's it. This scalar function. How do you write that one? Again, so triple integral x, y, z square dx, dy, dz over this region, okay, over this region. So then how do I write? I'm going to, so I can write this one like this actually, x dx, okay. So let me think of a limit later. So then a y variable dy, okay, y variable dy, y integral, okay, y integral. So then, look at here. So z variable is z square dz integral. Write like that, isn't it? You can always, again you can do in any order, okay? You can do in any order. Is that okay? So as I told, you can take this line, you can first integrate y, you can find this line and you can just sweep that one through the triangle, and then you can do z1. or you can start with z1 also. Okay, so now this x integral, again it has got variable x. Now what is the limit? Limit becomes same as finding the volume, 0 to 1 minus y. Is that okay? 0 to 1 minus y. Y integral 0 to 1, z integral 0 to 3. Now you have a variable inside. Along with dx, dy, dz, you have a variable inside. So that will make a difference. Okay, can you just do this one quickly? Now look at here, when you just integrate this one, this will become function of y. Why? It should become function of y because you are finding one arbitrary length. So in between this region, you are finding arbitrary length. Remember, is it okay? At some y point. At some y point, then you are running y from 0 to 1. Okay, so now look at here. Yeah, so think over it again. Okay, just draw the diagram and think over it. So x will run from, so let me write 0 to 3 z square, 0 to 1 y. What is this one? X square by 2. Can I write 1 minus y the whole square by 2? Directly do it in your way, isn't it? X square by 2 running from 1 minus y, 0 to 1 minus y, 1 minus y the whole square by 2. I am writing directly. Do it in one more step. Don't look at the board. Isn't it? Or let me share some more. I think Sham series books are the best one to practice in a less time. Should I do this one? I can write z square dz because when you find this one, you will get a constant. It will come outside. Okay, integral 0 to 1. I think how to write this one? Y into y square plus 1 minus 2y dy z cube by 3, that is 9 by 3. Am I right? No, 27 by 3. Z cube by 3. Z cube by 3 running from 0 to 3. Y cube y to y square. I think 1 by 4 y raised to 4 by 4. Am I right? 0 to 1 plus 1 by 2 minus 2 1 by 3. What is this one? Quickly. So 3 cube is 27. Am I right? So 27 by 3 multiplied with 1 by 4 plus 1 by 2 minus 2 by 3. 1 by 12. What is that one totally? 3 4 the 3 9 the 3 1 the 3 3 the 3 by 4. 1 by, where I left 1 by 2? Where is 1 by? Oh, this 1 by, this 1 by. Correct. 3 by 8. Now the similar problem is there here, but here it is finding the area. I mean area with along with some functionality. Okay, we shall do that problem also. I think that is problem number, so 1.34. 1.34. 34th problem in the first chapter. Okay. So practice this one. So 2 here, 2 here. He asked to verify Stokes theorem. Am I right? Isn't it? He asked to verify Stokes theorem, but let me do only that area integral. Okay. So now our vector field here is V is equal to xy into x cap plus 2yz into y cap plus 3zx into z cap. Okay. Now he said verify Stokes theorem by giving this loop integral, isn't it? To verify Stokes theorem, what we do? We first do this line integral, this closed line integral. Then we will take any surface enclosed by this closed loop. Am I right? So plane is the simplest surface enclosed by the closed loop. And we are going to take the plane and we are going to take surface integral. Am I right? So what is that one? Closed path integral of v bar dot dl bar. So that's equal to surface integral of curl of vector field dot dA vector. Isn't it? Now this can be any surface whose boundary is this path. Am I right? Now I am doing this, so this path integral. I can take any surface. What is the simplest surface? This plane itself. Why we have that freedom? Because this surface integral is independent of the surface chosen. It depends only on the boundary line, isn't it? So plane itself is the simplest one, and we are going to take that one and we are going to show those two are equal, isn't it? Now let me do this part. In that part again you will get this kind of integral. Is that okay? Let me do this part. So now I have already shown the path integral direction, isn't it? It is in this direction. That's why your area vector should be along this direction. What is this one? X cap, y cap, z cap. Your area vector should be along x cap. Am I right? What is your area vector? What is the elementary area? It is a yz plane. Am I right? dy dz. It is along x cap. Why along x cap? Because I have it like this. Okay. So if your fingers runs along the path integral, your thumb will represent the direction of the area vector, isn't dA vector in this one, isn't it? So now I have to take again I have to take curl. Can you just find quickly? Find the curl. xy, 2yz, 3zx. So be little fast in writing the step. Don't skip any step, okay? X cap into 0 minus 2y minus y cap into 3z minus 0 plus z cap into 0 minus x. Check it out. Minus 2y into x cap minus 3z into y cap minus x into z cap. But I am taking del cross v dot dA. Am I right? Look at here. What happened? Okay, no. Plus z cap 0 minus. Be careful, be careful. Write down all steps. Write down all steps. Now remember, in exam hall, usually to study that one we need mathematics, this level of mathematics. I mean, we need to do lengthy steps like that. But in exam hall, you will have very less question with a very long mathematical step. Or you should not choose those kind of questions. You have to avoid them if it has very lengthy mathematical step. Then again, so time doesn't matter. Is that okay? If you want to attend those kind of questions, there will be less number of questions. That's why you better write each and every step. Don't skip that one. Okay. Now, once you try to skip that one, definitely mistake will happen. Okay. Now look at here. So dot dA vector is along x cap. What is that one? Minus 2y into dy dz. Am I right? Can I write directly? Dot product with this vector and this vector. X cap dot x cap equal to 1. X cap dot y cap equal to 0. X cap dot z cap equal to 0. So now you have to double integrate this one. Minus 2y dy dz. So throughout this region. Throughout this region of the plane. Is that okay? So now again the same technique. Again the same technique. Shall I write here again? Again the same technique. So 2 here, 2 here. What is this equation? Y equal to x, 2 minus x. Check it out. slope equal to minus 1 again, y-intercept equal to 2. So now what we have done earlier, this is, wait a second, that's z and y variable, wait a second, z here, y here, z is equal to 2 minus y, is that okay? Z-axis is playing the role of our y-axis earlier, y-axis is playing the role of x-axis, okay? Now, wait a second, what we have done earlier, I found this one, am I right? I found this line first. So that was 0 here. If suppose this was z, what is this value? Y equal to 2 minus z. Am I right? This was 2 minus z. Am I right? First, integrate minus 2y dy from 0 to 2 minus z. Y integral first do from 0 to 2 minus z. That you will get this equation of the line. Then integrate along z-axis from 0 to 2. You better draw that one, unless you will not get clear picture what we are doing over there, okay, geometrically. This is x-axis, am I right? This x-axis. Now look at here, what would happen? Minus 2 obviously outside, 0 to 2. So y square by 2, that means 2 minus z the whole square by 2 dz. Again, that variable will be there. Obviously, it should be there, isn't it? Unless this becomes variable, how you can sweep throughout the triangle, isn't it? So got cancelled. Minus 0 to 2, 2 minus z the whole square. How do I write? 2 minus z the whole cube by 3 with one more minus 1. Am I right? So just check it out. 0 to 2. Is that your answer? 2 minus z the whole square, 2 minus z the whole cube, whole divided by 3, and coefficient of z. Okay? Upper limit 0. Lower limit, yeah, upper limit it should be 0. Am I right? Look at here. When z equal to 2, this length is 0. That will make it 0. That's correct. 2 cube by 3. Am I right? Check it out. No, I have 2 minus z. Am I right? Yeah, upper limit minus lower limit. Yeah, you are right. One more negative. Okay. Here I cancelled one more sign because of that integration. Okay. Do it yourself or elaborate from this step. From this step, do it in your way. Yeah, he's asking what if we get a cone? If we get a cone, we better to go for cylindrical coordinate. Okay, cone, sphere, spherical coordinate, cone, cylindrical coordinate, isn't it? We have taken that kind of problem in classical mechanics. Am I right? So cone has a cylindrical symmetry. That will be very easy in that particular coordinate. Okay, in Cartesian also you can do that one, but limits will be very difficult. Is that okay? Limits will be very difficult. Now, can you take any integral calculus book? So, how to find area of a circle using Cartesian coordinate? Area of a circle using Cartesian coordinate. That would be, you have to take the limit properly. I too forgot that one. Isn't it? But in plane polar coordinate, it is one step integration. Isn't it? What is this one? Integral of r square dr d theta. Yeah, r square dr d theta, that's it? No, r dr d theta. Am I right? Area element in case of plane polar coordinate, we have taken couple of days before. Area element in the plane polar coordinate, r dr d theta, isn't it? When you integrate this one from 0 to a, theta from 0 to 2 phi, what will you get? You will get pi r square. You can check it out. So check that out. R square by 2 into 2 phi. Isn't it? So that's how it works. Whenever symmetry allows, so you have to go for that particular coordinate and you have to do that one. Okay. So he has given questions on that one. Okay. He has given, I don't think he has given much question on cylindrical symmetry, but spherical symmetry he has given enough question. Okay. Later you can just practice on it. Is that okay? But here this can be done in Cartesian coordinate, and it is easy in Cartesian coordinate only. Is that okay? If you go for polar coordinate, that would be very difficult. Why we will go for polar coordinate here? Any idea? Because of again symmetry only. It's a kind of symmetry problem. Is that okay? Now, any sphere you have to go for spherical polar coordinate. Any cone you have to go for cylindrical coordinate. Any bowl you have to go for cylindrical coordinate. Why? When you rotate that one about z axis, it will be symmetrical. Am I right? So just remember that fact. Okay. Yeah, I think he has given spherical one on a sphere, not a cylindrical one.